Now that you've learned a lot about combining random variables and finding their means and standard deviations, and how is this going to look in a problem? Okay, so here is a problem involving the normal model where we were adding random variables. And something I wanted to remind you of is that if we add two variables that are both normally distributed, their sum is normally distributed. We learned that back in chapter 2, so I just wanted to remind you of that. It does not change the shape when we add those two random variables. So suppose the height m of male speed daters follows a normal distribution with a mean of 68.5 inches and a standard deviation of 4 inches. So let's go ahead and write down things we know. So the mu of m is 68.5 inches. And the standard deviation, so sigma of m is 4 inches. And then we have females. We found that the mean of the female speed daters follows a normal distribution with a mean of 64 inches and a standard deviation for the females of 3 inches. What is the probability that a randomly selected male speed dater is taller than the randomly selected female speed dater he is paired with? So basically speed dating is a bunch of men and women are in a room and there's a bunch of little tables, and a man and a woman sit down at the table and they have like 5 minutes to sort of get to know each other, and then the timer dings and then they switch tables, and so they get to meet a lot of different people, and if they think they might be interested, they'll exchange phone numbers and maybe go on a date. That's basically what speed dating is. So we have taller men and shorter men, and so what's the probability that in a randomly selected pair of people in this speed dating situation, the man is taller than the woman? So this is what we're trying to find. The probability that m is greater than f. So that's our question. So how does this translate to a sum or a difference of two random variables? Well, m is greater than f could also be written as the probability that m minus f is greater than 0. In other words, since if the male is taller than the female, when we subtract their heights, we'll get a number bigger than 0. So this can be treated as the difference of two random variables. So what we're going to do is use our rules to find the mean and standard deviation of this new combined random variable. So I will put this in a different color. Mu of m minus f would be the difference of the two means, because we've learned that we just add or subtract the expected values or the means. So this would be 4.5 inches. So I would expect on average that the difference in height between a randomly selected man and woman would be 4.5 inches. Now the sigma of m minus f. Well, remember, when we subtract two random variables, we still add their variances if the variables are independent. So it would make sense that a randomly selected man and women, randomly selected man's height and woman's height are independent. We have no reason to think that one has any relationship to the other. Because they're totally random. Now, if they were in the same family, for example, their heights might be related. Selecting someone's sister, for example, selecting the sister of a tall man might make it more likely that she is tall. But these are totally random individuals. So we can add the variances, which means we can add the standard deviation squared. So I can add up 4 squared plus 3 squared, which turns out to be 5 inches. So the mean and standard deviation of the combined, the difference of the two random variables are those variables, and the shape of the distribution is still normal, because if we combine adding or subtracting two normally distributed variables, the combination of those variables is still normal. So still approximately normal. All right, so now I want to know what is the probability that m minus f is greater than 0. All right, so let's create our model here. So this is the difference in heights. So I'm just labeling it so I know exactly what it is I'm talking about. Male minus female. And here's my distribution. It is normal with a mean of 4.5 and a standard deviation of 5 inches. So here's, let me redo that last line, that's kind of sloppy. So the mean is 4.5. I want to know the probability that m minus f is greater than 0. So if this is 4.5 and the standard deviation is 5, this is slightly less than 1 standard deviation from the mean, so this is about right here. 0 would be maybe about right here. And I want to know m minus f is greater than 0, so I'm looking at the area to the right of the curve. So I should expect my answer to be greater than 50%. Maybe around 75%. Not sure exactly. So the probability that m minus f is greater than 0, I'm going to use normal CDF, and I've got my lower is 0, my upper is infinity, mean 4.5, standard deviation 5. So I'm going to label these lower. Don't just label it L, because somebody might not know what you mean by L. You can use the symbols for mean and mu and sigma because those are standard symbols in statistics. This turns out to be fairly high probability, which would make sense. Fairly high probability that a randomly selected man and woman, the man's taller than the woman. So let's summarize. There is about, remember we say about because this is just a model representing a situation, about an 81.6% chance that a randomly selected male speed dater is taller than his randomly selected female partner. I don't know if I'll say randomly selected. Male speed dater, yeah, I guess I'll say that, is taller than his randomly selected female partner. Okay, so there's an example of using a combination of two random variables to do a normal model problem.